The next thing that we're going to be going through is numbers. Now Salesforce has, I'm going to clear this out real quickly. Salesforce has multiple number data types. It has integer, long, double, and decimal. Integer is 32-bit, which only can have whole numbers. Now with it being 32-bit, it means that the max number is a little over 2 billion and the minimum number is negative 2 billion. And so just to show that, we can do integer I is equal to 4 billion. And this should error. And then if I do the same with integer I equaling negative both of these should have an error. You can see here, illegal integer. This one as well, illegal integer. And then if I do A2, that one worked. And this one worked as well. Now, again, because it's supposed to be whole numbers, if I do 3.2, and remember a string has the single quotes, this doesn't have single quotes, which is where it's denoting it to be a number, and then illegal assignment from decimal to integer. So that's where if it has a decimal in here, it's automatically going to assume that it's a decimal data type. And then obviously integers themselves cannot have decimals. All right, a long is a 64-bit number that only has whole numbers as well. So a long is going to be pretty much it's an integer, but it has many more numbers that it can go through. Like I said, it's because it's 64, the max number is 2 to the power of 63, and the minimum number is negative 2 to the power of 63. So a very large number. And then decimal and doubles, they both have the ability to have decimal point based numbers. So then to go through a few different things with these numbers, if I do integer x is equal to 2, integer y is equal to 3, then I can do arithmetic with these as well, where I can do x plus y x minus y, oops, x times y, and I can see in the debug I have 5, negative 1, and 6. So then I can do the same thing with doubles. And then 3.2, or not doubles. Doubles works as well, but I'll be using decimal for this. Double is just the long version of the decimal. And then 1. So if I do just a debug of W, because this is a decimal, it is going to, it looks like it's an integer, but really because we denoted it as a decimal, it is a decimal. So then also if I do t plus w equals to z times w. We can see again 2, 4.2, and 3.1. So the most common data types that I use is going to be integers and decimals, and all of these also have the value of function, so you can turn anything into these data types as well, such as a string that looks like it's supposed to be a decimal or an integer. You can use value of to do the same thing. So then the last thing that I wanted to leave you with is rounding mode within the decimal class. This is going to be strictly within the decimal class. So if you want to round a number, you can use the decimal class and then the round methods. Within the method, there are also multiple ways to round. So then I'm going to first do, one thing that I want to show as well is, I haven't done this yet, but this is in order to write comments within Salesforce or Apex. You can write anything that you want in here, and when you run it, it's going to be left out when you run it. So this is going to be the ceiling. And so with the ceiling, if I do decimal y equals 6.7, and then decimal x 1.1, okay, so then if I do y, because I'm using the decimal, so round is the method within there, and then it's going to be using their system rounding mode ceiling. And then I'm going to do the same thing with x. And now when I run, even with this comment in here, it's not going to cause an error. So I can see that's 7 and then 2. So what ceiling does is it moves the numbers to the positive infinity. So this being the next positive infinity is going to be 7, and then for x, it's going to be 2. So the next one is down, which this is going to round towards 0. I can't type. I have decimal y, we'll do the same thing. So we'll do some copy and pasting to save some time. And then instead of ceiling, we'll do down. And as you can see here within the editor, there is a down. There's also a half down. I won't be going through half down. If you want to take a look at that, you can. But you can see here that's trying to help me with putting that in as well. And I can see that's trying to round it towards the 0. So I have 6 and then 1. So even if I were to make these negatives, I have -6 and -1. So I was trying to get it towards 0. So the next thing that I want to show is floor. Now floor rounds to the negative infinity. Floor negative infinity. So we'll do it this way where we have a positive and then a negative. And then run that. And we can see we have 6 and then -2. So it's the exact opposite of ceiling. There's several other roundings that you can do. If you wanted to take a look at that, it's pretty interesting to go through the decimal class documentation, and you can see that. And you can see the different rounding modes that you have that are available. And that's going to conclude this lesson.